Now we'll take a look at some examples using the theorems. Before we do that, even though this is 5.5 and we're talking about the side-side-side congruence theorem and the hypotenuse-leg congruence theorem, let's quickly review the other theorem that we went over, and then we'll just basically keep a running list. So we have a few different ways right now to prove that two triangles are congruent. Don't forget, if you have all the corresponding sides of one triangle congruent to all the corresponding sides of a second triangle and all the corresponding angles are congruent, then the two triangles are definitely congruent. That's a definition of congruent triangles. But the ways that we went over so far in chapter 5 to prove that two triangles are congruent, we started off with side angle side. Don't forget that the angle has to be included between the two sides. Then we also have side, and then I kind of want to say finally the hypotenuse-leg theorem that we've gone over so far, but there's other ways that we'll cover in the next sections that two triangles are congruent. So just because we're concentrating on 5.5 on side, and hypotenuse-leg doesn't mean we won't use side angle side. Okay, so on the examples here, it says decide whether the congruent statement is true, explain your reasoning. So by explaining your reasoning, you really should be using one of the theorems. So on number 1, triangle ABC is congruent to triangle EDC. And then if you take a look at the two triangles, I have all three sides of triangle ABC congruent to all three sides of triangle EDC. AB is congruent to ED, BC is congruent to DC, and then AC is congruent with EC. So those two triangles are congruent. Yes, that's a true statement, specifically by the side theorem. And then on number 2, if you take a look at that, and some of you might be saying, well, only two sides of triangle KGH are congruent to two sides of triangle HJK. But here's something that you have to keep in mind. Side HK is the same length in both of the triangles. So HK is congruent with itself, specifically by the reflexive property. Even more specifically, by the reflexive property of congruence, not the reflexive property of equality, because we're talking about a segment length or a segment, and a segment is congruent with itself. So these two triangles, KGH is congruent to triangle HJK, again by side, even though we kind of didn't start off with that. And then on example or problem number 3, triangle UVW is congruent to triangle XYZ. So you have all three sides of this triangle congruent to all three sides of this triangle. And then you might say, well, okay, then those two triangles are congruent by side. You need to be very careful here. Because if you look at the congruent statement, it says triangle UVW. So UVW is congruent to triangle XYZ. And the way that this congruent statement is written, vertex or angle U has to be corresponding with vertex or angle X. And those actually do not correspond. Even though these two triangles are congruent, it would be something like triangle UVW is congruent with triangle, and what corresponds with U is Y. So it would be Y. What corresponds with V is X. And then what corresponds with W is Z. So triangle UVW is congruent to this triangle, but it would have to be triangle YXZ. This is not a true or a correct congruent statement. So in this case, it's actually no, because the sides or the vertices or the angles are not corresponding. And lastly, on number 4, triangle RST is congruent to triangle RPQ. Similar to the last example, all three sides of this triangle are congruent to all three sides of this triangle. You just need to make sure everything matches up or is corresponding. R, this vertex, corresponds with R in each of the triangles. So on this left side or the top triangle, R corresponds with R in the bottom or the right side triangle. Okay. S corresponds with P, so RS does correspond with RP, and then T corresponds with Q. So yes, specifically by the side congruence there.